and at the end of the session, 3 or 4 hours after the end of the session, I will send you a file, and you'll be able to review anything that we
sounds good.
go over or that I draw on my whiteboard. Your mom said you were having some trouble with the Pythagorean identities.
Yes.
What's this one equal to?
1.
Okay. Notice this one is slightly different. What's that one equal to?
That one's equal to secant squared theta.
And these are really the only two you have to memorize, because the third one is the cofunction of that and the cofunction of that. So it's cotan squared of theta plus 1 equals cosecant squared of theta.
Right.
So I believe in only memorizing the minimum amount and then working out the rest of it. I think that that's kind of the secret of memorizing stuff. And certainly with trig, you've got a ton to memorize.
Right.
Probably what sets trig apart is how much stuff that you have to memorize.
Right.
Okay, so have you just begun this trig course, or?
I took it last semester, and I got to the same spot, and I just could not pass it to save my life.
Okay, so what do we need to do? Do you have some exercises we can work on, or?
Yeah, I have like a review quiz that I have to do.
Perfect.
So, yeah. Let me see if I can find it.
Can you verbalize the problems to me?
Yeah.
Okay. Now, some of them are liable to be tough to verbalize if they, for instance, show you a graph and say, what's the sinusoid equation of this graph?
Right.
That would be tough to verbalize, and the best way to handle problems like that is for you to take a picture with your smartphone and email it to me.
Okay.
And then I can bring it up on the screen so that we can both see it.
Okay.
But as long as you can verbalize them, we can proceed with working verbal problems.
Okay, sounds good.
Why don't you state it and I'll write it.
Okay. Let's see. I know, like, okay, so most of them, like, I get, it's like these, like, you have to get an 8 on the quizzes and stuff to move on, and I, like, get, like, 6 or, like, a 5, so I just can't get, like, 8 out of 10 on it.
Let's find some problems that you don't know how to do.
Okay.
Then let's start
so the ones that I really struggle with is this one. So it says find all the solutions to the following equation in the interval 0 degrees greater than or equal to theta greater than 360 or less than 360. And then the equation is 2 sine squared theta minus sine theta equals 1.
What we have here is a quadratic equation. It's no different than this.
Okay.
Okay? It's called a quadratic in sine of theta. This one is called a quadratic in x. This one is a quadratic in sine of theta. And we want to solve it exactly the way we would solve a quadratic, which would be to put everything on one side and factor it.
Right.
Okay, so I'm going to move the 1 over. And now let's factor this.
Okay.
And if it's useful, substitute x for this and factor this one.
Right.
And then we'll just resubstitute sine of theta when we're done. But after you do that a couple of times, you don't need to do that substitution.
Right.
Okay, that's how it starts. What's the rest of it?
And then it is minus 2 plus 1.
Okay. Let's examine, first of all, the process of factoring.
Okay.
Once we get our first two spots, now I'm going to examine the sign on that and
Right.
know that it has to be plus minus or minus plus. It's the only way you can produce a negative. So let's try plus minus. There are only one pairs of factors of 1, and that's 1 and 1.
Right.
Does this work? Well, this produces a middle term of sine theta
Right.
and an outside term of minus 2 sine theta. When we add those together, we get minus sine theta. That is our middle term, so we've done it right.
Right.
So in terms of the factoring, we got the factoring right. And now I can say that this whole thing is equal to 0. And now what's the next step?
You said both of them equal to 0 separately.
Okay, so let's solve on the left side over here. Sine theta plus 1 equals 0, or sine theta equals minus 1.
Right.
2 sine theta. So sine theta is equal to minus 1/2.
Right.
Where in the unit circle does that occur?
So sine is a y. So it happens.
Let me ask you something.
Yeah.
Have they had you memorize the unit circle?
Yeah.
Have you memorized?
Yes.
Very good. Personally, I don't like that method of learning trigonometry. I think it's too difficult to memorize the unit circle.
Right.
And I have a shortcut method where you only have to memorize 3 or 4 things at a time. But if you've memorized the unit circle, then let's just deal with that. And where is the sine of theta equal to negative 1/2 on the unit circle? At what angles? First of all, which quadrants? Let's start with that.
It's going to be in either quadrant 2 or 3.
Well, sine is positive in 2. Sine is positive in 1. But it's negative in 3 and 4.
Right.
Now, one thing that's helpful is this little thing. All students take calculus.
Yes.
You're familiar with that?
Yeah.
Okay, and that means that everything is positive in the first quadrant, only sine and its reciprocal in the second, only tangent and its reciprocal in the third, only cosine and its reciprocal in the fourth. So if we're looking at where sine is negative, it's got to be the third and the fourth quadrant.
Right.
So what's the angle where it's equal to negative 1/2?
Is it a 45-degree angle?
Well, it's a 30-degree angle.
A 30? Okay.
Yeah, now let's maybe go through that. It might be worth me showing you how I figure out my unit circle.
Right.
Because memorizing it is really tough.
Right.
Okay? Let's start. Let me go back to the following. Let's go back to our 2 special triangles. These are the 30-60-90 and the 45-45. And if you memorize the dimensions on this triangle, you can get all of the trig functions of angles that are multiples of 30, 45, or 60 without memorizing anything else.
Okay.
So looking at those 2 triangles, what's the sine of 30 degrees?
Sine is opposite over hypotenuse, so it's 1/2.
Okay, so there's our angle. It's the 30-degree angle. But it's a 30-degree angle in the third quadrant. In other words, this reference angle is 30 degrees right there.
Okay.
So what is the total angle? from there to there?
It's 210.
Okay, so there's one theta. It's one solution. How about in the fourth quadrant? If we're looking for a reference angle of 30 degrees in the fourth quadrant, how far is it to there?
330.
Okay, so that's the second solution for this part of the
Right.
problem.
Okay.
Okay, well, we also have sine of theta is equal to 1.
Uh-huh.
So if sine of theta is equal to 1, where does that occur? That occurs if I look at the graph of sine. This is another thing you really want to memorize.
Mm-hmm.
So what angle, oh, excuse me, you probably are in degrees everywhere. Have you touched on radians or not?
Yeah, we have.
Okay, but since this problem was set in degrees, in other words, they made the domain degrees, so let's leave it in degrees. So where's the sine equal to 1?
90.
Okay, so, and notice that there's only one place.
Right.
Any other angle, there's two places where it can always be. But if it's a quadrangle, it's only going to be in one spot. In other words, there's only one place where it's equal to 1, and there's only one place where it's equal to minus 1.
Mm-hmm.
Notice that there are multiple places where it's equal to 1/2. It's equal to 1/2 there and there. It's equal to negative 1/2 there and there. So it's only the quadrangles that you're only going to find one solution. So here's our three solutions that fall between 0 and 360.
Uh-huh. Okay.
Okay? And that's exactly the way you want to do every kind of solving a trig equation problem.
Mm-hmm.
Is once you, usually they come down to quadratics, not all of them, but let's do another one.
Okay. And then there's another one.
I'm going to leave these two triangles up there because they're so important.
Okay, sounds good. So it's the same like beginning part, but just a different equation.
Okay.
For the next problem. So it's 4 cosecant squared theta minus 3 equals 4 and then parentheses cotan squared theta plus sine squared theta and then end parentheses.
And theta is in the unit circle, and we have to solve for this.
Yep.
Okay. Well, let's see. We have a relationship between cosecant squared and cotangent squared. Mm-hmm. What is our Pythagorean identity regarding those two?
Cotan squared theta plus 1 equals cosecant squared theta.
Okay. So let's see if we can use this to help solve this problem. There weren't parentheses around this, right? I wrote the left side properly?
Yep.
Okay, so let's distribute the right side. So I'm going to make that 4 cotan squared of theta plus 4 sine squared of theta.
Okay.
Get rid of the parentheses. That's the first step. Okay. Now, for
could you like move all the stuff with the 4s to one side and then the 3 to the other and then take out the 4? So then it's like cosecant squared.
Yeah.
Like
Okay.
Cotan squared.
That's a good start. What we want to be able to do is replace the cosecant and cotangent with a number. And we're going to be able to do that. In fact, let's factor out that 4 and write it like this. We'll go ahead and put that sine squared theta in there also.
Okay.
Okay. What is this equal to?
-1? Because it's a minus?
Yes. So we have 4 times -1 minus sine squared theta equals 3.
Right.
So,
And then you could divide the 4 from the left side and put it on the right side.
okay.
Right?
Yeah. Let's do that. Now, what is -1 minus sine squared theta? What's the Pythagorean identity regarding sine and cosine?
Yeah. So
Notice that 1 minus okay, let's do this a different way. Let's not use the Pythagorean identity because we can't use it. There's no way I can construct a -1 minus sine squared theta. But let's take this 1 on the other side. So now we have minus sine squared theta equals 7/4. So sine squared theta would equal minus 7/4.
right.
And there's a problem immediately. If I take the square root of both sides,
You'll get an I on the right side.
even if this was a positive, it's not going to work.
Yeah.
Because the domain of sine of theta, or rather the range of sine of theta, is from -1 to +1. In other words, this makes no sense. This cannot be. Sine of theta always has to be a number whose absolute value is less than or equal to 1.
Right.
So even if this was a plus, and I took the square root of both sides, I would have the sine of theta equals square root of 7/4, which is also greater than 1. So this has no solution.
And that's like the thing I would say there was no solution, but like the math thing that I'm taking says there is a solution. Like there is no option for no solution. There's either 1, 2, 4, or 8 solutions.
Okay.
I have to put a number in.
Well, let's see if I made a mistake in my math here. Do I have this correct? 4 cosecant squared of theta minus 3 equals 4 cotangent of theta plus 4 sine squared of theta?
It's 4, and then in parentheses, cotangent squared theta plus sine squared theta. So yeah.
So after I distribute it, it's this.
Yep. Yep.
So when I moved all my trig functions to the left, they have minus signs in them. When I moved my 3 to the right, I've got to turn my camera off here. When I moved my 3 to the right, it became plus.
Right.
And this, did we do that Pythagorean identity correct? We did, because it's cotangent. Maybe we didn't here. It's cotangent squared theta plus 1 equals cosecant squared theta. So cosecant minus cotangent is actually a positive one.
Okay.
Okay?
Okay.
Now we're in business because
Okay.
notice that what is that equal to?
That's cosine squared theta.
Okay, so now we have cosine squared theta equals 3/4. Now we're in good shape.
Right.
Take the square root of both sides, and what do you get for cosine of theta?
You get the square root of 3 over 2.
You actually get plus or minus the square root of 3 over 2. And this plus or minus is very critical because that gives you two more. There's going to be two solutions for the plus, and there's going to be two more solutions for the minus.
Okay.
Okay, now if we go back and look at this triangle, what angle is the cosine of theta equal to square root of 3 over 2?
So it's adjacent over hypotenuse. So it's the 60.
It's the 30.
30. The 30.
In other words, if I said, what's the cosine of 30 degrees, you would take the adjacent over the hypotenuse.
Right.
So the cosine of 30 degrees is square root of 3 over 2.
Right.
So that must be one of our solutions, 30 degrees.
Mm-hmm.
Where else is cosine positive in the unit circle?
Is it positive
All students take calculus.
in the fourth quadrant?
Okay, what is the angle that will give you a reference angle of 30 degrees in the fourth quadrant?
330.
Okay, there's the second solution for the positive square root of 3 over 2. Now how about the negative square root of 3 over 2? We've got to find two solutions for that.
Right.
Which quadrants are they going to be in?
So it's going to be in quadrant 2 and 3?
2 and 3, yes. What's the angle that is going to be to give you that reference?
150.
150?
Yep.
And in the third quadrant?
Is going to be 210.
There's our four solutions.
Okay, perfect.
But if we didn't put that plus or minus down, we would have only gotten two solutions.
Right.
Okay?
Okay.
People always forget that, and I'm not sure why. I think it has to do with the following. If I say the square root of 9, that's 3 by convention. If I want negative 3, I got to do this. That's negative 3.
Right.
But if I say, if I give you an equation, and I say x squared is equal to 9, and I solve this by taking the square root of both sides, well, now it's plus or minus 3.
Right.
Because minus 3 squared is 9 also. So both of these are very valid. But you only have to use it when you're solving an equation and you're taking the square root of both sides.
So if you put it in, you have to have the plus or minus.
Yes. If I say that, that's 3.
Right. Okay. Perfect.
Okay.
So then I have like one more, well, I have two more of the same problem, same type of problem, but it's like it's not the same as those two. It's like a different.
Yeah, no, let's go through these. Solving trig equations it can be pretty tough.
Mm-hmm.
You have to really know your identities well.
I've never struggled so much with math in my life. So.
Well, you probably just got finished with a chapter where you had to prove trig identities.
Yeah.
There is no reason on earth why anybody would ever have to prove trig identities. You know why they make everybody do that?
No, why?
To get you to learn your identities.
Yeah.
There
Okay. That's
are
a good reason why.
there's like 11 key identities.
Right.
And you can memorize them, but the way you'll really learn them is if you spend about an hour trying to prove trig identities. By the time
Okay.
you get done proving an hour's worth of proving trig identities, you'll know all your identities. And that's
Right.
the only reason they make you do that. Now,
Yeah.
solving trig equations is a different story. There's all kinds of trig equations in the world that we have to solve. But
Right.
in order to solve trig equations, you also have to be really good with your identities. You'll
Right.
notice that on that last problem, I screwed it up because I got this identity wrong. I got -1 instead of +1.
Uh-huh.
And the problem became no solution just by that one mistake.
Right.
Okay, let's do another one.
Okay. So it says using Pythagorean identities to find cosine theta given cotangent theta equals 2.9 and cosine theta is greater than 0.
Okay, I love these kind of problems. One way to do these problems, and as far as I'm concerned, only one way. And that's to start out drawing a right triangle.
Right.
You don't care at the moment, and labeling theta.
Okay.
Now dimension this triangle. If cotangent of theta equals 2.9, how can I dimension my triangle?
Cotangent is cosine over sine.
Well,
So it's
more importantly, it's adjacent over opposite.
right.
So
So
let's
it's
make the
2.9
adjacent.
on the bottom and then 1 on the left.
Okay, now once we've dimensioned two sides of this triangle,
Yeah.
we can figure out the hypotenuse.
Uh-huh.
So the hypotenuse is going to be what? The square root of this squared plus 1? Do you have that number handy?
No. Here. Let me put back my calculator real quick.
It's going to be approximately square root of 10.
2.9 squared plus 1.
And then take the square root of that.
And then the square root of yes.
Guessing 3 point something.
I can't find the square root on my calculator.
Raise it to the 1/2 power.
There we go. Perfect. I can do that. Oops.
Or raise it to the 0.5 power.
Square root of is 3.067.
Okay. 3.067. We'll just leave it at that. So now that we have this triangle fully dimensioned, I can tell you what any trig function is of theta. What's cosine of theta equal to?
Cosine of theta is adjacent over hypotenuse.
So it'd be
2.9
over 3.067.
Okay.
And it's positive, so that's all we need. Now, the way these problems will typically be structured is they'll say cotangent of theta is 2.9 and we're in the second quadrant. So if that was the problem, now what's the cosine of theta?
So it's going to be negative 2.9. Because
Yeah, actually we couldn't be in the second quadrant, could we? In other words, cotangent's positive in the third quadrant, but negative in the second. So this would have to say, okay, we're in the third quadrant, so now the cosine of theta is still this number, but it's negative.
Right. Yeah, both of them are negative.
Okay.
Okay.
So that's all you have to do with these problems is draw a triangle, put the 2 dimensions on it that you know, figure out the 3rd dimension, and then read your trig function from the triangle.
That's so much easier than the way they taught us. It's like
It is. It
what
really
they
is.
taught us to use was like the equations and to like plug things in and then remember other equations.
So let's do a few more like that. Make sure you got it.
So it says use a Pythagorean identity to find sine theta given secant theta equals negative 1.1 and sine is greater than 0.
Equals negative 1.1 and sine is greater than 0. Now the only thing wrong with the technique that I used was we didn't use the Pythagorean identities.
Okay. Well, on this like math course that I have or whatever, they don't look at any of the work you do. It's just the answer. They don't really care how you get there, just as long as you get there.
That truly is the hard way to do the problem, is by using the Pythagorean identities.
Right.
But if you don't have to do that, this other method is so much easier. So what's my first step?
So you draw a triangle, a right triangle, and you label theta.
And it can be either one. Doesn't have to be the lower right.
Right.
Okay.
And then you put the numbers in.
Okay.
So secant is the reciprocal of cosine. So it's 1 over that number.
Okay. So
1.
What's the hypotenuse equal to?
The hypotenuse is 1.
1.1. And this side is 1.
Right.
Notice that this makes the secant of theta equal to 1.1.
Okay.
Divided by 1. Now we're going to ignore that for a moment.
Okay.
Okay? What is this other side?
The other side is...
It's going to be the square root of 1.1 squared plus 1, minus 1 squared.
Squared minus...
Let's see, 1.1 squared must be 1.21, so it's the square root of 0.21.
So it's 0.458.
0.458. And again, we're ignoring sine.
Mm-hmm.
So where is the secant negative and the sine positive? What
so would it be...
Actually, you know what? At this point, we don't even need that. Because they've told us the sine is positive, then what's the sine of theta?
The sine of theta is opposite over hypotenuse.
So 0.458 over 1.1.
Yeah.
And we don't even have to figure out what quadrant it's in. But this must be the second quadrant. Because there's only one quadrant where secant is negative and sine is positive, and that's the second quadrant.
Right.
Because secant is reciprocal of cosine, cosine is negative in the second.
Okay, perfect.
Okay.
Okay. So then I have one more that's a little bit confusing, and then that's all of it, I think. So all it says is cotan parentheses 90 degrees minus theta equals blank. And it wants me to fill in the blank.
Why is that the case? Let's look at our 30-60 triangle again.
Okay.
And when you memorize this triangle, memorizing those basic dimensions I call this my unit special.
Right. Okay.
On the 4545, sometimes the classrooms like to call this square root of 2, square root of 2, 2, instead of 1, 1, square root of 2. Either is fine. Either one gives you the same ratios.
Okay.
It's just this one kind of makes sine and cosine already rationalized. Whereas if you use 1, 1, square root of 2, you end up with 1 over square root of 2, and you have to rationalize that, and it becomes square root of 2 over 2.
Right.
So it doesn't really matter. In other words, I really could put an x with each of these, and it could be any multiple of those three numbers. But to not confuse the issue, I just leave the x off, and I say this is my unit triangle. Well, notice that the sine of 30 degrees is 1/2, but the cosine of 60 degrees is 1/2. And in fact, the sine of theta is always equal to the cosine of 90 degrees minus theta. These are called cofunctions. And all cofunctions, and cofunction meaning cosine differs from sine because it has a co in front of it.
Right.
Cotangent is a cofunction of tangent, and cosecant is a cofunction of secant. So all of these, or excuse me, secant of theta is equal to cosecant of 90 degrees minus theta, and vice versa. And tangent of theta is equal to cotangent of 90 degrees minus theta.
Okay.
So we had cotangent of 90 minus theta. That's equal to tan of theta. And cotangent of theta would also equal tangent of 90 degrees minus theta. In other words, there's actually 6 relationships here.
Right, but those are the 3 that you need to know.
Yeah, in other words, you really only need to know one. And that is that cofunctions always have this property where the cofunction is equal to the function of 90 degrees minus the angle.
Okay.
Okay?
Sweet.
So what came after this one? You said it was a fill in the blanks. That was our first blank?
Yeah, that was it. Yep. And then that's it, actually. That's really like the ones, and then everything else is just like factoring, which is, I can do that. And then
there's some that can be a little tricky. Let me just mention one.
Okay.
How would you solve this?
That's a good question.
We want to turn it into a quadratic in either sine or cosine. In other words, it's very difficult to solve trig equations when you have 2 different trig functions in the equation. So you want to try to get one trig function.
Okay.
Well, what is a good trig function to work in here? In other words, I have an identity that lets me turn that into cosine squared.
Right. It's it would be 1 minus cosine squared theta.
Now we have a straight quadratic.
Okay. Okay.
Got to distribute it.
Right.
And now let's make sure we have a positive coefficient in front of this, and let's make this a -1 just to make it come out nicely. When I pulled it out of thin air, I didn't know how it was going to factor. So this is what we're looking at. So we can combine that and this. 2 minus 1 is plus 1.
Right.
Now I'm going to divide both sides of the equation by -1 to turn it into this. Now I can factor it.
Right.
Into what?
So it'll be it'll be -1 plus 1.
Good. That gives us a proper middle term.
Okay.
And that's the only, whenever you're factoring, you never need to check the left term or the right term, because the way we do the factoring, we guaranteed that those are correct.
Right.
The term that's always in doubt is that middle term. So when I'm done factoring, I always do my little smiley faces thing and make sure that this is a minus cosine theta, this is a plus 2 cosine theta, add them together, I get plus cosine theta, which is the middle term I desire.
Perfect.
Okay, and now you know how to solve that.
Yeah.
Set each one of them to 0 and solve for theta. So that is a pretty common problem that you're going to likely run into, where they give it to you with two different trig functions, and you need to use the Pythagorean theorem to turn it into a quadratic of one trig function only.
Right.
Okay. Well, I'm perfectly content with ending the session now. If you don't have any other problems to cover, I don't charge a minimum of an hour or anything, so I'll just charge you 3/4 of an hour.
Okay.
And my online fee is $32 per hour. So 3/4 of that must be what?
Is 24. Perfect.
Okay. And yeah, it's fine if your mom sends a check. That's the way she was paying for your sister, right?
My sister. Yep, my sister.
What was your sister's name again?
Jackie.
Jackie, that's right.
Yep.
And your mom's name is Arlene. Yes.
Yep.
Okay. So we're good to go. If you want a regular appointment, let me pull up my schedule here. I don't know if this is just a one-time deal for you, or if you're interested in having a one session a week or something like that.
When I get this is the only section I don't get out of this whole this whole chapter really, because I get everything else. I've been going super fast through everything else.
Okay. Well, good.
But when I get to calculus, I might need a little help. So that'll be in the fall.
Okay. And my fee structures used to be I had a higher price for calculus. I don't anymore. In other words, my calculus fee is the same as my trig fee.
Okay, perfect.
It's $32. So if you have any problems with trig or with calculus, feel free to call me or email me, and I'll be happy to work with you.
Definitely.
Okay. Now, whether or not you want this copy of this file that we just created,
yes.
you do. I need an email to send it to. Let me see if I have. I don't think I have your email. You want to get it to me? Let me write it, and that way I'll make sure I'm writing it correctly.
Okay.
And then it takes about 3 hours for me to process it, but then I'll send you a link where you can play it in YouTube format immediately.
Okay.
What's your email?
RNL 123 at
Comcast.net?
Yep. .net.
How'd you get such a simple email address?
I actually made it when I was 8.
Ah, that explains it.
Yep.
There's no three-letter combination with 1, 2, 3 that's available on any three letters.
Exactly. It's
Right.
perfect. It's my
Right
first, middle,
now.
and last name, so
Yeah.
I'll never forget it.
Yeah. Okay. Good. I will send you that link by tomorrow morning. And
Okay, that's
just
perfect.
click on the link and you'll be able to view that recording. You can fast forward it if you want, pause it,
Okay.
do anything you can do with a YouTube file.
Okay, perfect.
Okay. All right, Rachel.
Thank you so much.
You're welcome, and good luck in the rest
Thank
of
you.
your class. Talk to you later. Bye-bye.
Okay.